Oh. Good morning to one and all. Good morning.
Hello.
Hello. Good morning. Hello. My
Sir.
voice is audible to you. Please mute. My voice is audible to you.
Yes, ma'am.
My screen is visible to you.
Yes, ma'am.
Okay. Shall we start today's lesson? Okay. Previous class we are discussed about that what are the interferences that are occurred in digital modulation techniques. So one is an interchannel interference. Do you understand what is an interchannel interference? Interchannel interference. Two different signals are transmitted on time sharing basis. They are mixed. That means one symbol of one signal is mixed with another symbol of another signal. So two symbols are different from different signals are mixed together. So that is nothing but a cross-talking, or generally that can be called as an interchannel interferences. And intersymbol interferences. And intersymbol interferences, only one signal is there here, single signal. Let us assume single signal. We are sampled that signal. Here sampling is at this one. Another sample value is at this one. After encoding, we are given some coding for this one. Let us assume some 101 for a value of this
Hello.
sample.
Ma'am.
Amma, waiting.
Ma'am, allow cheyamantunaru ma'am.
Okay, I will allow. Okay, so this is a symbol for this sample. Another symbol for another sample is let us assume 0, 0, 0, 0, 1. Let us assume only. So these are symbols for same signal. So this symbol is overlapped with this symbol, same signal, different symbols, adjacent symbols, both are. They are overlapped together. That is inter-symbol interference. Please note down. Inter-symbol interference. Interchannel interference. This is a one signal, and this is another signal. The sample of this one is this one. Here we can indicate this is sample value. The code for this sample is some 0, 0, 1. Let us assume this is a sample of another signal. The value for this one is 0, again 0 or 1. Let us assume. So this is a symbol of one signal, and this is symbol of second signal. In TS duration, you have to transmit both the signals. So during this transmission, these two symbols for two different signals are overlapped together. That is an inter-channel interference. interchannel interference. These are the major differences between inter-symbol interference and interchannel interference. So those both are occurred in these digital modulation techniques because of your using digital data. Okay. Then now here and again last class we are discussed that disadvantages of BPSK complexity and here we have to in BPSK two disadvantages. One is complexity and the second one is we can't identify the transmitted bit is B of T or minus B of T. Inverse of that one is you can't identify it in a BPSK. So here we are using this DPSK differential phase shift keying, that problem can be solved. So here in DPSK, by using this logic at the transmitter here, we can use at the transmitter D of T is the data signal that can be passes through exclusive OR gate. Then output is delayed by TB. Then the output of exclusive OR gate is passes through that balanced modulator. That is at here we can use the carrier is root of 2ps cos omega naught t. Then output of this one. So then that signal is received by receiving antenna and that can be processed to DPSK receiver. The output of the receiver, you will get the data is the product of B of T and B of T minus TB with the TB duration. So okay, from this one, how we can recover the signal. Here we can, how we can recover the signal. This is very, very important. Okay. Now, here we can observe the waveforms of DPSK. Please refer to that. Go to this waveforms of DPSK. Here the output of receiver, the product of B of T minus TB, two are obtained at the output of receiver. Both are obtained at the output of DPSK receiver. These two are obtained. So at this one here we get B of T. Another one is B of T minus TB. In this case, the output is obtained not directly. Here we take decision. Here we can obtain the output depending upon the decision. Here B of T and B of T minus TB product. Here we can observe that we can product of these two. Here B of T minus TB. So this is 0 indicates that minus 1 volt. In terms of volts, again here we can indicate that this is a minus 1 volt. Then minus 1 volt positive, then the product is equal to 1. Okay. Again, in this one is, this is minus 1 volt. Again, this is minus 1 volt. Then minus minus positive, that is positive. And here we can indicate that 0, 1, 0 is minus 1 volt and plus 1 volt. The output, the product of these two is a negative. Negative. And again here, this is a plus 1 volt, this is minus 1 volt. Here that is an negative. Emma, audible to my voice? To you? My voice is audible to you?
Yes, ma'am.
Okay. Then ఫాలో అవుతున్నారా నేను చెప్తుంది వేవ్ ఫార్మ్స్ దగ్గర అవుట్పుట్ ఎలా మనం డిసైడ్ చేయాలనేది. ఓకే. సో హియర్ దిస్ ఈజ్ అన్ 0, this is 1. Again the output is low. The output is low. Here also the output is low. And again here you can observe that B of t is high and B of t minus tb also high. Therefore here this is an 1. And again both are high. The product is 1. Then this is a 1, this is low, that is low. Again that is both are low, output is high. And both one is high, one is low, therefore that is low, and another one is high. So this is the product of B of t minus tb is obtained. So here we can indicate that the phases for this one here. So here positive, positive, negative, 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 positive, positive, negative, positive, negative, positive. So positive indicates, here we can indicate that there is no phase change. Here we can indicate that positive indicates that here there is a phase change. Negative, here we can indicate that negative. So product of these two, P of t and B of t minus tb is, here we can observe that this is a product of this B of t minus tb. We can observe with this d of t. Here we can observe that d of t. So here we can indicate that this is an B of t and this is a B of t minus tb. Here we can observe that if positive indicates that at the input d of t is an opposite to this phase. Here the product of these two positive, that indicates that here we can indicate that so the output is out of phase with this product. That is d of t is predicted like that. B of t and B of t minus tb is positive, that indicates that the d of t is negative, that means 0. ఇక్కడ పాజిటివ్ వచ్చింది కాబట్టి జనరల్ గా మీరు ఇక్కడ ఆపోజిట్ వేసుకోవాలి. అంటే -1 వోల్ట్ ఉంది అంటే 0. సిమిలర్లీ హియర్ ఆల్సో ప్లస్ ఉంది అంటే +1 వోల్ట్ ఉంది, పాజిటివ్ ఉన్నది. సో దేర్ఫోర్ హియర్ దట్ ఈస్ an opposite phase, that is a 0. D of t is a 0. Here we can take the decision here. The product of these two is not an answer here. From that product here we can take the decision. Decision, that is the result is D of t is depending upon the decision, not product. Here we can remember this point. That is very important. Here this is a 1 minus is there. So the actually the received data is an opposite phase of this one. Here this is a minus. So that is minus 1 volt. That indicates the D of T is opposite. So that is an plus 1 volt. That indicates that the logic 1. Here is the logic 1. Here is the logic 1. Here is the logic 0. That is D of T. Here this is an minus is there. D of T is 1. This is 0, 1, 0. So are you observe that according to that output product, here we can take in the decision. So product manaki output of that DPSK receiver, the product is positive. That indicates that so plus 1 volt vaste manaki data received data so minus 1 volt ani until that is a logic 0 ani here we can understand. Like that here, but taking that decision here, we obtain that output. Not directly here we can take D of T. Here the output D of T is taken by decision. The product is equal to positive. That indicates that D of T is a negative. That is equal to 0. Minus 1 volt indicates that the logic 0. If that is the product B of T and B of T minus TB is negative, that indicates that the D of T output is in positive plus 1 volt. Like that here we can detect the D of T. Here D of T and D of T. Okay. So here we can take any data stream. This is very important. So in external question paper, have to give this is the data stream that can be passes through DPSK signal. So what is in B of T? Have to draw the waveforms, relevant waveforms for that one, and how to recover the data. You have to draw all those things. D of T is this one, B of T minus TB, B of T and B of T minus TB product. From that one, how we can recover, how we can take the decision. These all those are very important. Okay, are you understand the operation of this one? Hello? Hello?
Yes, ma'am.
మీరు ప్రొడక్ట్ అవుట్పుట్ అని అనుకోకూడదు. ఇక్కడ ఈ పాయింట్ గుర్తుపెట్టుకోండి. బి ఆఫ్ టీ మైనస్ టీబీ ఇస్ ద అవుట్పుట్ ఆఫ్ ద రిసీవర్, డిపిఎస్కే రిసీవర్. దట్ ఈస్ నాట్ ఎన్ అవుట్పుట్. బేస్డ్ ఆన్ దట్ వన్ హ్యావ్ టు టేక్ ద డెసిషన్. ఓకే, డెసిషన్ మేకింగ్ అనేది తీసుకోవాలి. ఆర్ యు అండర్స్టాండ్?
Yes,
okay?
ma'am.
Okay. Then, so what are the disadvantages of this DPSK? Now, we will discuss the disadvantages of DPSK. In DPSK, it has two disadvantages are there. Here we can observe that that receiver block diagram and integrator also operated at carrier frequency. The frequency that operation receiver block operated at carrier frequency because the terms obtained at this receiver is B of T at the integrator. I will B of T minus TB, B of T minus 1 into TB. Sorry, T minus TB, 1 delay, and another one is cos of omega naught into TB. This term is obtained at this receiver. That means omega naught is the carrier frequency. That means the overall receiver is block diagram is operated at high frequency. So that is one drawback. But in BPSK, the integrator is operated at only baseband frequency. Double frequency term that can be deleted or rejected by integrator that operates only B of T and B of T term. B of T is a modulating signal. So that's why here BPSK is a receiver is a operated at baseband frequency, whereas in DPSK is operated at carrier frequency. You have to note down. The DPSK receiver operated at carrier frequency. This is the one drawback. And the second one is bit errors. The second one is in bit errors. The bit errors occurred in DPSK is in terms of pairs. Pairs means here, in this one, the feedback path that can be used. So B of T is fed back to input as the second input to the exclusive OR gate. So B of T minus TB. The output is depending upon the product of B of T minus TB. That means the current bit and previous bit. Here, based on these two bits, here we can take a decision. What is the output? So therefore here, if that is one bit is error during the transmission, there is a possibility of pairs of bits is in error. That means, so that is current D of T is depending upon, bit is depending upon previous one, B of T minus TB. So there is a chance for single bit errors and double bit errors.
మ్యామ్ అలౌ చేయమంటున్నారు మ్యామ్.
Okay, please note down. The second disadvantage is there is a possibility in single bit errors and double bit errors or errors in phase and pattern. Double bit and count the error in phase occurs errors in phase because the decision of the output is depending upon B of T minus TB. B of T minus TB. Okay, so these are the drawbacks that can be present in DPSK. These are the drawbacks that can be present in DPSK. What are the disadvantages? The receiver is operates at carrier frequency, and second one is errors in bits are occurred. There is a possibility for single bit errors and the errors in pairs. Double bit errors also occurred in DPSK. So therefore, to overcome these two problems, you go for another phase shift keying method is DEPSK. Sorry, DEPSK. DEPSK. Please note down this one. Differentially encoded phase shift key. DEPSK, D differentially E encoded phase shift keying. In this differentially encoded phase shift keying, the transmitter, please note on, the transmitter is same as the transmitter block diagram is same as the transmitter block diagram of DPSK. DEPSK transmitter block diagram is same as the transmitter block diagram of DPSK, differential phase shift keying, and the receiver block diagram is similar to BPSK, with additional circuit in DEPSK. There is a hard decision is used for generating output signal. Okay, so in DPSK, please listen to me. In a DPSK, the output D of T is considered or generated according to decision of from that product B of T and B of T minus TB. That means if that is B of T minus TB, so both are one, the output is positive, that indicates that actual input is out of phase with that one. Like that, here you can take in decision according to that levels of that B of T minus TB products. But in this case, how to use hardware, that means one circuit, and from output of that circuit is nothing but a D of T. There is no decision. ఇక్కడ B of T minus 1, B of T minus TB minus 1 రెండింటిని ప్రొడక్ట్ చేస్తే పాజిటివ్ వచ్చింది కాబట్టి అవుట్పుట్ నెగిటివ్, యాక్చువల్ డేటా బిట్ ఈజ్ నెగిటివ్ ఉంటుంది, 0 అని మనము అలా డెసిషన్ అలా ఉండదన్నమాట. జస్ట్ ఆఫ్టర్ generating B of T, that signal is passes through that hardware circuit. The output of the hardware is nothing but a D of T. That is an additional circuitry is used in DEPSK when compared with the DPSK. So clearly here you can understand the transmitter of the DEPSK is same as the DPSK, and the receiver block diagram is similar to BPSK, and some extra circuitry is used. And compared to DPSK, in DEPSK, always one bit is an error always occurred, that errors in pair always occurred, errors in pair. Whereas in DPSK, there is a possibility of single bit errors, and due to that some reasons errors in pairs also occurred. But whereas in DPSK, even then during the transmission, any bit is one bit error that can be occurred at the output of the DEPSK receiver, that errors in pair is present. That is the drawback for DEPSK, and complexity is increased by using these DEPSK when compared with the DPSK. So okay, so now here you can draw the transmitter block diagram of DEPSK. మీరు ఫాస్ట్గా డ్రా చేయండి. ట్రాన్స్మిటర్ బ్లాక్ డయాగ్రామ్ ఎలా ఉంటుంది? ట్రాన్స్మిటర్ బ్లాక్ డయాగ్రామ్, transmitter block diagram is similar to DPSK, same as the DPSK, not similar, same as the DPSK. DPSK transmitter block diagram enti? Make it fast, please draw this. DPSK, this is the data signal that can be passed through exclusive OR gate. Output of this one is B of t, that can be delayed by delay. Delay TB, that is second input to exclusive OR gate, that is B of T minus TB. Then output is given to balanced modulator, So here the second input is carrier signal root of PS cos omega naught. This is a transmitter block diagram of DEPSK, differentially encoded phase shift keying output. Next, receiver block diagram. Receiver block diagram. In DEPSK, the receiver is similar to BPSK. The complex circuitry is used here. So that is, the received signal is a DEPSK signal. This is the dip that can be given to square law device. Please note, this one is square law device. Then the output of square law device is given to band pass filter. It allows double frequency term. The output of this band pass filter is passes through frequency divider. The frequency divider divided by 2. The output of this one is carrier. Again, this is input to synchronous demodulator. The second input is direct received signal. Then the signal is passes through integrator and bit synchronizer. Here, integrator, This is a bit synchronizer. Bit synchronizer. Then here the output of this one is B of T. Output of this one is an B of T. Here we can use additional circuitry. Here we can use additional circuitry. This signal is, please note, passes through exclusive OR gate. So this is the D of T. The output of this one is D of T. Passes through delay network. Delay network. Delay by T bit duration, that is second input to the exclusive OR gate. The output is D of T. So please note down here. Here the output D of T equal to B of T, B of T exclusive OR with B of T minus TB. Okay, here we can observe that all of you, my screen is visible to you.
Yes, ma'am.
Are you understand what is the difference between DEPSK and DPSK? And how we can recover the data signal D of T, original data signal from this output B of T. Here this is the additional circuitry that can be used. Exclusive OR of B of T with B of T minus TB, you will get the actual D of T. So this is a hardware that can be used to detect the D of T. But whereas in DPSK, just by using that product here, we can take a decision. Okay, after are you noted these block diagram are completed?
Yes, ma'am.
Then you go for waveforms. Shall we go for waveforms? అబ్జర్వ్ చేద్దామా, ఎక్స్క్లూజివ్ ఆర్ చేస్తే వస్తుందో లేదో చూద్దామా. డి ఆఫ్ టీ వస్తుందో లేదో మీరు చూడండి ఒకసారి. మీరు కూడా డ్రా చేశారు కదా వేవ్ ఫార్మ్స్. ఆ రెండింటిని బి ఆఫ్ టీ మైనస్ టీబీని ఎక్స్క్లూజివ్ ఆర్ చేస్తే వస్తుందో లేదో చూద్దాం. గర్ల్స్ ఫాలో అవుతున్నారమ్మా? గర్ల్స్ నుండి నాకు రెస్పాన్స్ రావట్లా. Okay. This is actual, this is output depending upon decision. Here in DEPSK, output is exclusive OR of B of t minus dB. Okay. So minus 1, B of t exclusive or with B of t exclusive or with B of t minus dB. Change. Are you getting D of t? D of t వస్తుందో లేదో చూడండి. You are forget about this one. ఇది డెసిషన్ మీద డిపెండ్ అయింది. ఇదేమో DPSK. Here we can forget about this one. Forget about this one. Here we can consider B of t minus dB. We can exclusive OR with these two signals. ఇక్కడ -1, -1. -1 is nothing but a logic 0. 0, 0 to the exclusive OR gate. ఆ రెండింటిని ఎక్స్క్లూజివ్ OR చేస్తే ఎంత వస్తుంది మనకి? చెప్పాలి అవుట్పుట్. Exclusive OR of 2 zeros. Hello? Hello? My voice is audible to you?
0 ma'am.
0. Very good. మరి చెప్పడానికి ఏంటమ్మా ఎంత టైం తీసుకుంటున్నారు? Why you are taking so much of time? Wrong or right? You have to tell your answers. ఏమా? నో అసలు మీరు ఏమీ ఫీల్ అవసరంలా తప్పవుతుందా కరెక్ట్ ఆర్ నాట్ అనేది. యువర్ ఆన్సర్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. వాట్ ఎవర్ మే బి దట్ ఆన్సర్, యువర్ రెస్పాన్స్ ఈస్ వెరీ ఇంపార్టెంట్ టు మీ. నెక్స్ట్ గర్ల్స్ చెప్పండి. నెక్స్ట్ చెప్పాలి. గర్ల్స్ ప్లీజ్ రెస్పాండ్. హియర్ మైనస్ లో ఉంది, ఇక్కడ కూడా లో ఉంది. అంటే లో అంటే 0, 0. వాట్ ఈస్ అవుట్పుట్ ఆఫ్ ఎక్స్క్లూజివ్ OR గేట్? హలో, ఎవరు రెస్పాండ్ అవ్వట్లేదు గర్ల్స్? అగైన్ దిస్ ఇస్ 0. అగైన్ హియర్ 0, 1. Output is 1. Again this is 1, 0. Output is 1. Here this is 0, 1. The output is 1. Here 1, 1. The output is 0. Again 1 and 1. The output is 0. Again here low and this is 1. The output is 1. Again that is 0, 1, 0. So this is an exclusive OR of B of t and B of t minus dB. This isn't depending upon decision. So here this is DEPSK output. So there is no decision. There is a hardware is used to generate D of t signal. This is the advantage of DPSK when compared with the DPSK. But disadvantage is that circuit complexity is increased because of additional circuitry is used. And the second one is bit errors are in phase are obtained in DPSK when compared with DPSK. Okay?
Okay ma'am.
Please note down disadvantages of DEPSK also. Right. The disadvantages of DEPSK is the errors are occurred in phase, always in phase. The errors are occurred in phase. The receiver circuitry is very complex. The receiver circuitry is very complex. Advantages of DEPSK. hard decision is used here. Hard decision is used. That is B of t exclusive or with B of t minus tb. Here the hard decision is used. That is B of t exclusive or with B of t minus tb to get output, to get the output d of t. Okay. Okay. Any doubts in this lesson related to phase shift keying? Anybody have any doubts?
No, ma'am.
Waveforms and equations అన్ని నోట్ చేసుకుంటున్నారమ్మా మీరు?
Yes, ma'am.
Please note down, and you have to refer the top and shelling principles of communication systems. Top by top and shelling direct గా ఉంటాయి waveforms.
అదే ఎప్పుడైనా తెప్పించుకోవచ్చని తెలియని పెట్టే పారైపోయినా.
ఓకే,
ఇలా మోకాలు నొప్పి అన్నా.
ఓకే. F3 please mute. Okay, shall we stop here? Next class we will discuss about the quadrature phase shift keying. Next one, QPSK. Okay, please respond.
Okay, ma'am.
Okay, మీరు ఒక్కలే రెస్పాండ్ అవుతున్నారు. వాట్స్ యువర్ నెంబర్?
A9, ma'am.
A9. వెరీ గుడ్. మిగతా వాళ్ళు కూడా రెస్పాండ్ అయితే నాకు తెలుస్తుంది. వెరీ గుడ్. మీరు ఎప్పుడు రెస్పాండ్ అవుతా ఉండండి. ఓకే,
Okay, ma'am.
ఓకేనమ్మా. నెక్స్ట్ క్లాస్ we will discuss about QPSK. Okay, shall we stop here? Thank you Ananda.
Thank you, ma'am.
థ్యాంక్ యూ. గర్ల్స్ అసలు రెస్పాండ్ అవ్వట్లేదు. ఏం క్వశ్చన్స్ అడగను, మీరేం చెప్పినా నేనేం అననమ్మా. ప్లీజ్ రెస్పాండ్ అందరూ. మీకు వీ హ్యావ్ టు కన్వే యువర్ ఐడియాస్. నాకు తెలుస్తుంది కదా, ఏమి అందరూ తప్పేం లేదు. మీకు తెలిస్తే చెప్పండి, మేడం ఇలా అనుకుంటున్నానండి అని చెప్పండి. నో ప్రాబ్లం. రికార్డ్ అవుతున్నా సరే ప్రాబ్లం ఏమీ లేదమ్మా. నేను మామూలుగా మాట్లాడిస్తున్నాను కదా, మీకు అర్థం అవ్వాలని. ఓకేనా? యూ హ్యావ్ టు కన్వే యువర్ ఐడియాస్. మీకు అర్థమైందా లేదా అనేది ఇంపార్టెంట్. ఓ చెప్పేయటం కాదు కదా. ఓకేనా? ప్రతి ఒక్కళ్ళు మీకు అర్థమైంది అని చెప్తేనే నేను ప్రొసీడ్ అవుతాను. లేదు అంటే మళ్ళీ ఒకసారి రిపీట్ చేస్తాను. ఇక్కడ అర్థం కాలేదు మేడం అంటే మళ్ళీ ఒకసారి రిపీట్ చేస్తా. ఓకేనా? ఏం భయపడొద్దు, చక్కగా మాట్లాడండి, ఫ్రీగా ఉండండి. ఓకే, థ్యాంక్ యూ అమ్మా. థ్యాంక్ యూ.
Thank you, ma'am.
థ్యాంక్ యూ.
Thank you.